Hello, everyone, and thank you for joining us for today's session. My name is Askia, and I'm the facilities coordinator for the Redmond Reactor Space. Before we start today, I have a few things I'd like to go over, so please take a moment and take a look at our code of conduct, which is right here. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared throughout the chat. And this session is going to be recorded and will be available in 24 to 48 hours on our Microsoft YouTube channel. So it'll be available on demand. And that's going to bring us to today's session, which will run for approximately 1 hour. And we'll have time for questions before the session is finished. So now I will turn it over to our speaker and we will let her get started.
Okay. Thanks, Askia. Hi, everyone. My name is Ruth Yakubu, and it's a pleasure to be presenting at Microsoft Reactor. In today's session, I'm going to be talking about how to expose machine learning model errors, data bias, and interpretability using responsible AI. So for this session, the agenda is first, I'm going to go through the principles. So just in case I'm going through a lot of concepts, don't worry. At the end, we're going to do a deep dive hands-on demo. But before we get to the demo, I'm going to be sharing the responsible AI principles. Then we're going to go into talking about gaps in evaluating machine learning models. If there are gaps, okay, why is it so important to debug? Have tools that can debug our model further to identify where there could be potential risk when it comes to harms and responsible AI violations. Then lastly, after we go through all of that, I'll give you guys a hands-on demo on how you can implement use the same tooling and evaluate your models using the Microsoft Responsible AI Toolkit. Then also, I'll try and save at least 10 to 15 minutes at the end of the session for all the questions that you have. So as I'm going through each section, please post your questions in the chat window, and we'll try to get through everybody's questions. Sound good? Okay, sounds good. So it's an interesting time when it comes to responsible AI. I know every speech that people give, they always mention that, but truly it has been a remarkable year, I'll say, in responsible AI, especially with the rapid innovations that we're seeing with AI and also with open AI being available in the generative area, AI, chat GPT, all of that is what is on top of everybody's mind now. So this is very exciting, and we're seeing advancements and breakthroughs in AI happening at a very rapid rate. The next thing is companies are investing a lot of their dollars or a lot of money into making sure they adopt AI into their business processes, like internal business processes, to make their workers or their processes more efficient. And also with the products that they're putting out there for consumers to consume, how can they make infuse AI in those products to be more intuitive and intelligent, and also give them a competitive edge. Another area we're seeing is with society. People's opinion are increasing when it comes to AI, good or bad. We're seeing that a lot through all the conversations that everybody is having around responsible AI. Then also we are seeing governments now take a little more stance or initiative to try and regulate AI in response. We see that more evident in some industries, let's say for healthcare or for national services, but obviously we have a long way to go. So these are the different reasons that responsible AI is on top of everybody's mind. When you ask, okay, why is this so important? Number one, when I say society's expectation is evolving, there's a lot of scrutiny. There's a lot of anxiety as well in terms of what is AI doing? Is it harmful? Is it trustworthy? That sort of thing. So people are asking questions. We're also seeing a lot of news headlines of information of the misuse or the use or misuse of AI, good or bad, and kind of like how I mentioned with governments taking steps to start putting together processes to regulate AI. So when we talk about responsible AI, the very first question we need to ask ourselves is, what is responsible AI? Is it just a term that people use to make sure when we're building these models, we're just responsible people, or what is it? So in terms of like Microsoft principles that we practice is when we're talking about responsible AI, we're talking about fairness. So making sure models that we produce out there are fair to individuals or society, not giving opportunities to one group and restricting it to another similar group that could potentially benefit from those privileges. That's one example. Another thing is reliability. When we put out models out there, how reliable and safe are they there? So that's another area of responsible AI that we need to look into. We when we go through the checklist, we making sure we're exhausting all the possible things that could potentially go wrong, out the outliers that we may not be thinking about that could potentially bring a negative impact to end users or um, um, whoever is engaging with the AI system. Another thing is privacy, security and privacy. So when it comes to security and privacy, that also comes with the data that we are using to train the model. And also with after we produce a model, how is it respecting our privacy and what security is it providing for the end users that are engaging with the systems? The inclusiveness may sound like, okay, it's the same as fairness, but when we're thinking of inclusiveness, a prime example is there are about 1 billion people with disabilities out there. In most cases, we think of maybe a disability, maybe somebody in a wheelchair or somebody with blindness, but realistically, almost majority of us have some kind of disability, whether it's color blindness. I can't speak today. Maybe that's another disability. Color blindness, or people that may have dyslexia. So that just shows that as we're creating AI models, how are we considering a large demographic that could benefit from this AI that we're leaving out? Then the next thing is transparency. How are we ensuring that we are providing transparency in models' behavior? So let's say AI system is being audited. We need to be able to explain why a model made a decision that it made. Let's say for a health diagnosis, or let's say a loan approval, whether somebody was approved or not, that sort of thing. So transparency is very important when it comes to AI models. Then lastly is accountability. Accountability, that's something that lies with even the AI developers or data scientists, all up to stakeholders that are driving the initiatives of AI. So those are the different areas when we talk about responsible AI that it applies to. So one of the exciting things is the ability to be able to debug AI models. So for the longest time, we were implementing AI models. We have great traditional ways of debugging models to make sure we're minimizing bias. We're also minimizing the error rates in models, and also looking at things like accuracy, how accurate the models are. But all of these are calculations, and it doesn't expose some of the core things in terms of what's it called? Responsible AI. So let's say you have a model. How are you demonstrating that a model is fair? Also, with error, how do you analyze and ensure that your model does not have errors in certain demographics, that sort of thing. So, since this is a challenge, a lot of academics out there, a lot of companies like Fairlearn, Interpret ML, and even Microsoft Research have been working on open source tooling for the data science community to help provide toolings for the developers and machine learning professionals to be able to debug models to make them improve the performance, make them less harmful, and make them more trustworthy. So one of the things that Microsoft has done is create the Responsible AI dashboard. This was launched at build of last year. It was incorporated into Azure Machine Learning Studio. But one of the great things is, since this is a very important area, there's also open source version that does the same thing. Obviously, yeah, you have added benefits when you're using the Azure Machine Learning Studio, but um, there is an open source tooling that's free to everybody. And we'll go into details around that. So the question is, what is this dashboard doing? So number one, it covers things like error analysis, data exploration, model overview, fairness assessment, model interpretability, counterfactuals when you need to debug models. Then also for decision makers, they have other components that are there to help them better make decisions that are more responsible given the insight. So those are accumulatively the interactive dashboard. those are the different sections and things that the dashboard provides. And we'll go into more details around that in our demo. So one of the gaps when we're talking about responsible AI, okay, what exactly is this tool doing? A prime example is when we train our models, we look at different metrics. So let's say for classification, we'll look at the accuracy, the recall, and the precision. And in this example, the model that was trained shows that there's 89% accuracy, which is really good. But realistically, when we look inside the model, there are different demographic. It could be a certain demographic where the model is accurate 100% of the time. It could then there may be in a demographic of data or people, or depending on what the use case is. For that demographic, the model is actually 42% accurate. So the question is, do we just blindly ship this model into production? What if this demographic in red is a key demographic for your business use case? What can make and break your model? But since this is a blind spot, you will not be able to see that. So the very good thing is the dashboard has a section called error analysis, where it's able to identify different areas, help you identify different areas where there's errors. So when we're talking about errors, just think of the model giving an incorrect outcome. The next area is around data representation. So when we look at data representation, we're looking at how the data is distributed, the data that you're using for your model to train your model. So it could be there's a situation where you have overrepresentation of your data. And for that demographic, the model would potentially be performing very well in that demographic. But there could be another demographic that there's underrepresentation. And with that one, the demographic could suffer negative impacts because the model is not performing very well in that demographic. And of course, there could be instances where there's a demographic that is not even represented in your data set. And this could even cause more problems. So these are examples of areas where there could be data bias can creep in and favor certain demographics versus another, and not even represent certain demographics. So when we get to data analysis, we'll show you examples of how to analyze and spot those type of unfairness. Then one thing that we're all aware of is when you create your model, after you train your model, it is a black box. It's when it makes a prediction, it's hard to really figure out, okay, for this use case, what are the key features that the model is using to drive its decision? So the good thing about the dashboard is there's a feature importance section that covers explainability and interpretability. So you'll be able to see, okay, for my model, what are the top features that are driving this model? Also, there could be areas in your data where on an individual basis, you need to figure out, okay, what feature, given a feature, what values within those features are also influencing a model's prediction. So once we get to those sections, start thinking of this being a black box. And this is also good when you're being audited or have to provide transparency. Actually, let's not get to the resources yet. So now that we covered the concept, let's get to the code to figure out if you have your model, how do you integrate responsible AI dashboard and be able to debug your model. So Askia, if you can transition to the screen with the browser, that'll be awesome. Okay, perfect. So the very first thing we do when we're training our model for the use case that I'm using is this is a classification use case. And basically what this model that we'll be training, that we trained, what it's doing is predicting whether or not a diabetic patient, after they're discharged from the hospital, what is the probability of them being readmitted back to the hospital in 30 days or less? So that's what this classification model does. To go through the source code, this is fairly straightforward, similar to models that you have. We're selecting the model that we're going to be using to train our model. We have our training and test data. As you can see, some of the data characteristics that we have in our data is the patient's race, gender, age, when they're discharged, what destination were they discharged, home or to a facility, that sort of thing. The number of time they spent in a hospital, the number of lab work that they have, so on and so forth. So you can see the different features that we're using to train this model. The next thing is we're going through data transformation. So we're doing pre-processing to encode our data before we train the model. So this is pretty straightforward, putting all of those steps into a pipeline. So when we're training a model, we have all the data already pre-processed. Then the next thing we do after the pre-processing steps is basically splitting the data, then actually training the data with our model that we're utilizing. So after we train our model, so everything up to this point is what you are probably doing. So whether you have a classification or regression model, you are going through all the different steps. You trained your model. You probably look at some of the model metrics. But the next thing that you're trying to figure out is, okay, now that I have my model, how do I actually go through and use a responsible AI dashboard? How does my model get to the responsible AI dashboard? So the two libraries that we utilize is the RAI widgets and the RAI responsible AI packages. So those are the two packages that you need in order to utilize to integrate your model and be able to extract insights to debug on the dashboard. So the very first thing that the dashboard needs is it needs to figure out of your the different features that you use to train your model. It just needs to figure out, okay, which ones were categorical features versus numeric. So with this feature metadata container here. Basically, you're just telling it, giving it the list of features that categorical features that you have in your data set. So once you have that, you have to, we use the REI instance, that's like the constructor. And all we need to do is pass in the model. So the model that you just trained, it needs training data and the test data. Since this is a classification use case, what is the target column or feature that we're trying to predict? So is it re-emitted or not re-emitted? The final prediction that the model produces. The next thing is we need to tell the constructor what type of use case are we dealing with. So in our case, we're dealing with a classification use case. So we specify that this is a classification. If you're doing regression, you specify that it's regression. Then also it needs to know, okay, what are the categorical features? You specify that. So once you have that in your instance object, the next thing is you need to figure out, okay, your dashboard. I went through some of the different components that are available in the dashboard. This is the area that you specify that, hey, I want the dashboard to have this component. I don't need this component, that sort of thing. So for explainability and interpretability, what we're doing is adding the explainer. That's the one that does the explanation of your model. The error analysis that I was talking about, we say we want to have that. Counterfactual, we're probably not going to have time to get into that. But there's a blog that goes into details. We'll see if we have time at the end. But yeah, we're saying we want to have the counterfactual component, and there's also causal analysis component. So we add all the different components that we want in there. The next thing is once we have all of that, we call compute on the REI insights. And when we call this is what's actually using our model to evaluate using the test data, and as it's evaluating the model, that's when it's extracting all the insights that are pertaining to the different components that you want to get details on. So due to time, I already ran this. I think it runs about 5 minutes or so, but it goes through and extracts all these insights from your model. Another good thing is as you create your model, one of the things that you can do is go ahead and create cohorts. So cohorts, basically what they are different groups that you potentially want to analyze your model. So if you see like a demographic that you want to analyze a little further, you can create a subgroup and call it a cohort for further debugging. So the cohort that I created here is a cohort that looks at patient's age and their prior inpatient. So inpatient just means prior hospitalization, whether it's greater than 1 or equal to 0. This step is really optional because identifying cohorts once you're in the error analysis is a little more effective than doing that before. But we still provide this available for you if you want to create, feel more comfortable creating the cohorts via code. Once you're done with that, you instantiate the dashboard. So you have your insights, you have your dashboard. So you're telling it that, okay, all the insights that I have, put everything into the user interface UI. So once you do that, what it does is it puts everything into one dashboard. It will provide a URL for you to go and debug your model. So now we're going to look at the insights that it was able to extract using our hospital diabetes hospital readmission use case. So similar to how I mentioned with the error analysis, this section, oh, the mouse is acting weird. So I'll try not to move my mouse there. But basically what this section does, all you're doing in this section is finding out all the different regions that there's a high error rate in your model. So where is the highest area that your model is failing to predict accurately? So the good thing about this dashboard, everything is color coordinated. So the darker the red, this one you can't really see, but each node, the darker the red, the higher the error rate. As the shade of red gets lighter, the lesser the error rate. So in this decision tree, when you look at the top node basically is showing you the number of correct predictions that were made by the model and the number of incorrect predictions that were made. So in this case, we have 994 total test cases. So you can also get that information. So in our test data set, we have 994, and the ones that are correct is 828. The ones that are incorrect is 166. So that's what this root node is basically showing. The next thing is these are the different nodes that are contributing to these errors. So if you're trying to figure out what exactly is contributing to the error, you can click on one node to look at the properties or the condition of the node, or you can click on, let's say, a base node or a sub node, and it'll show you all the different conditions for this demographic of users. That's one thing. The next thing is you can switch to a heat map and also be able to debug your model on an individual basis. So let's say I'm seeing that, okay, one of the top features that have errors is age. I can select age. As you can see, the percentage of errors look fairly small. So we could be like, okay, this is not a problem. We see patients, the top one is patients that are over 60 years old. The second one is middle age, so 30 years to 68, 60. Then the bottom one are the younger demographic, the 30 years old or younger. When we highlight on the cell, that's when it exposes how well the model is performing for this particular feature. So it shows that of in all the test data where patients are over 60 years old, 538, the model got the prediction correct, that they were going to be readmitted or not readmitted within 30 days. It got 122 incorrect. So when we first look at the error rate, let me go back to it. At the bottom, the error rate is 18.88%. So that means, okay, the ratio between correct versus incorrect seems pretty low, but when you look at the error coverage is high. And when you ask yourself, okay, what does error coverage means? It means for your all the errors that are coming from your model, all the incorrect predictions, is showing that 73% of the errors that are coming out of this overall model are coming out of this demographic of patients that are, 60 years or older. So one thing you can do is create a demographic. So if you want to investigate or debug further, you can click on the Save button, make sure the cell is selected, and give it a name. Let's say age over 60 years old. For this case, we're not going to do that. So we're going to get back to our decision tree. But these are examples of different areas that you can go to find out, okay, identify where your errors are coming from. Another thing it does is it'll also give you a feature list. So the feature at the top is the one that is having the highest error. So this is prior inpatient. For some reason, that feature is bringing most of the errors out of this model. So it orders everything in descending order, and that's also how you can figure out some of the features that are problematic, that your model is having a hard time. So to create cohorts to start investigating, what we're going to do is, since we know this path is the one that leads to the highest error rate, we're going to save this demographic of patients. And these patients are the ones where the number of medications that they're taking is greater than 18.5 or 18, and less than or equal to 21.5. So I'll say 22. And the prior inpatient is greater than 0. So the hospitalization in the past is greater than 0. So to save this, I'm going to prefix it as error, to know that this is a demographic that has the highest error rate. And I'll give it a name: prior inpatient greater than 0. And I'll also give it the number of medication, the number of meds that they're on is greater than 18. And the greater than didn't quite get in there. Okay, so greater than 18 and less than, I'll say less than or equal to 22. So I'll say less than 22. So that's one cohort that would identify that, okay, these patients are the ones that the model is having the highest accuracy. When you're also trying to debug areas where there's high error rate, one thing you also want to figure out is areas where the model is performing very well. So, okay, we know where it's erroneous, but what are the paths that the model is really performing well? So you can compare, like, what is so special about this demographic versus that demographic that is making the model perform better. So for this, looking, if I'm going to go the easy route of just looking at the colors, it seemed like this node and this root node are the ones with the clearer color. Then the next thing you can do is compare the error rate. This one has 5.96, and this one has 8.33%. So obviously this is the one with the least error rate. So what I'm going to do is also save this demographic of patients. So I'm going to give it their prior hospitalization or prior inpatient is less than or equal to 0. So essentially it's 0. The number of lab work that when they were in the hospital, they got was less than or equal to 56. Then lastly, on top of being a diabetic, what other health risk or health diagnosis do these patients have? So it looks like for the ones doing really well, the model performing really well, the diagnosis, other additional diagnosis is equal or less than 3. So we're going to save that. So that's all error analysis helps us do for us to create the different cohorts that we want to later on do analysis on. As you can see, this is 2 cohorts that I created. These were the ones that I created within the code that when we're coding. So this are the ones that are done in the code. So to look at the 2 that I created, one of the things that is good to do because you're doing comparative analysis, the very first thing you see is all data. So all data, this cohort is automatically going to be created by the dashboard. And it's basically showing the sample size. So it's showing that there are 994 records. These are the total test data. It's showing the accuracy. So the model, what is the accuracy of the model? So 0.84 is 83 is accuracy. We're seeing a very low false positive. So with this and a very high false negative when it comes to the outcome. So it's showing that for this model, it seemed like the model is doing um, uh, a the number of predictions that is getting incorrect for patients that are not going to be readmitted back to the hospital is very low. But the patients that are truly going to be readmitted back to the hospital, the false negative, meaning the model predicting it incorrectly, is very high, which is 0.8. When we look at the demographic of patients that had the highest error rate, we see that their sample is 25. So these are how many patients that fall in that category. Sure enough, when we look at the accuracy of that demographic, how well is the model doing predictions? It shows as 44. Then when we look at the false positive and false negative, it's similar to the rest of the overall data set. So we're seeing the same pattern. For the cohort that has the best model performance, the sample size is 335. And sure enough, that has the highest accuracy, which is 94, which is even greater than the overall model accuracy. For this one, it looks like the models, the patients that are not readmitted back to the hospital, all of them, it got correct. The ones that that are being readmitted back to the not going to be readmitted back to the hospital is getting almost all of them wrong. So these are the type of information that you can look at to start comparing and seeing where your model is performing well or not. Another area is as you create these cohorts, there's a section called probability distribution. So it'll show a graph for the different cohorts that you created. And if you look at the bottom on the x-axis, you see that it's basically showing, okay, what is the probability of patients in all these different demographics being not readmitted in 30 days. So as we see, this is all the data sets. The probability is pretty high. Most of them are not going to be readmitted, which is really good. The one that the model is performing very well, it's also very high. But the one that the model is erroneous, we see that its probability is slightly lower. One thing you can also do is change the metric. So see the opposite. Okay, what about readmitted? So it just does the inverse. The next thing is you can also look at the different individual metrics. So if we're looking at accuracy, we already saw it above, so we don't need to go into details in terms of the different cohorts. But you can choose between the different, metrics that you want. In our case, we're dealing with classification. So one of the things that it was important for us to specify whether the model was a classification or regression. That's what helps the dashboard bring the metrics that are pertaining to classification. If you specify regression, then all of these metrics will change and will be regression metrics. So when we look at the precision, we start seeing that, okay, the precision rate is going down for all the data. The erroneous one, demographic, it also went down. For some reason, the model that is performing well is still holding strong. So it's making the right prediction for patients that are not going to be readmitted back to the hospital. But when we move to recall, we see that the model is not doing a good job accurately predicting, making the prediction for the models that are for patients that are not going to be readmitted. You see that all of a sudden, the recall went all the way down to 0.13 or 0.14. For the erroneous one, went to 0.18. And for the demographic that was performing very well, we see a 0. So that means in that demographic, maybe part of the reason was none of the patients in that demographic had fell in the category of being readmitted back to the hospital. So that's why you're seeing a 0 there. The good thing is you can also, the dashboard provides a confusion metric. So you'll be able to look at that as well. So that's what's there for you to utilize. So we saw the overall data set. Another thing about the overall component here is you have the ability to actually debug the model on a feature level. So if you notice for the demographic where there's a high error rate versus the one with the less error rate, the common denominator is always the prior inpatient hospitalization. So we're seeing that patients, and once you select a feature, the good thing is the dashboard is automatically going to create the different cohorts for you for that feature. So for this, is showing that majority of the data have patients that have a prior hospitalization or inpatient less than 3. Then there are 39 patients that fall in the category of having prior hospitalization greater than 3 and less than 6. Then the next one is a demographic of patients that have prior hospitalization greater than 6. So similar to when we're using looking at the main cohorts that we created, you can see the different performance, compare where the disparities are also coming from. And one thing to keep note is even when you look at the accuracy, may be high or low, it's also important to take into consideration what is the sample size. Like if this was 44% or 30% accuracy, and there are only 5 patients in the sample size, okay, it's bad, but maybe it's not something to worry too much because it's not a significant number. So similar, you have the opportunity to go through the different probability distribution metric and confusion metric. The second to the last component that we're going to look at is data. So data analysis is very crucial. Data is a blind spot when it comes to debugging, but that's where most of the problems are. So for this use case of predicting whether a patient is going to be readmitted, one of the things you can do is to understand the model, you can look at the count. So we're going to change the y-axis to count, and we're going to look at the true y. So true y is showing that our demographic, most of the patients are not readmitted back to the hospital, and there's just a few that are readmitted back to the hospital, which is good. You don't want a hospital statistic showing that most people after they're readmitted come back to the hospital in 30 days. You can look at things like the actual prediction of the model. When we look at the distribution, we see that, okay, the model predicted less people being readmitted. So this is showing like an imbalance. There's an imbalance of data, as we can see. So the model is probably not learning well because there's such a huge disparity in terms of there's an over representation of the patients are not readmitted versus readmitted, and the model is probably not learning well, have enough data to really do a more accurate prediction. Another thing is when we're trying to investigate potential biases that may be in our data, we may also want to look at different features, like sensitive features. So when it comes to race, let's look at the count of overall data. How much, what is the distribution of patients in different races, ethnicities? So as you can see, Caucasian have majority, second to African American, Hispanic, and Asians don't have a representation. So when we just look at this data set, we know that there's an imbalance and potential risk of bias because there's an imbalance of data. Next thing we can do is look at, let's see, gender. And when we look at gender, it's fairly the same. So we may not need to worry too much about that. When we look at age, age also has overrepresent imbalance of data. But as we're investigating, we have to be very careful not to quickly identify something as bias or unbiased, because this may be a true representation of patients. Like the higher in age that a patient is and they have diabetes, there's more demographic of patients that fall in that category. So these are opportunities for the AI developer or the data scientist to work very closely with a specialist or the hospital practitioners to better understand that demographic. So the next thing we can do is also look at prediction. Look at, let's say, one of the features that we had was prior inpatient. So you can select a field and see, okay, how is the model doing for this prediction? So we're seeing that the lesser patient's prior hospitalization, the less likely the model is going to predict that they're going to be readmitted, which makes sense. If you have a tendency of having more hospitalization in the past, chances are, as a patient, diabetic patient, that means you tend to get sick easily. It looks like, yeah, there's a higher probability of being predicted that you're going to be readmitted. One thing I forgot to show you is, as you're going through all of these analyzing the data, you also want to pick the different cohorts, see the behavior of the model in one group of demographic of patients versus another demographic, or one cohort versus another, and look at the model's behavior. And that will give you an start understanding why is it that the model behaves a certain way with certain demographics of patients versus others. So let's look at the prediction rate when it comes to ethnicity. So it looks like there's no representation. The purple is Caucasian patients. When it comes to patients that are going to be readmitted, there's no representation for any of the ethnicities, but there is representation for the other ethnicities when it comes to the ones that are not going to be readmitted. So this is also a problem. It shows you a problem because just in case it could be the data that was collected in a highly populous demographic of Caucasian. But if you move the model to another demographic, that's when you're going to run into biases. Looks like we have 1 minute left. The final section that I'm going to go into is model importance. So model importance, basically what it does is it shows you what are the top features contributing to the model's prediction. So we can see inpatient, prior inpatient, age, race, prior emergency. These are the top features that are contributing to the model's prediction. One of the things, depending on the use case, when you look at the top contributing features, you have to also look at sensitive features. Let's say this was a loan application and is saying somebody's age or race or gender is one of the key factors driving a loan approval. That's when you can flag, know that, okay, there are potential biases. The good thing is the model also gives you an opportunity to look at individual data for individual patients. And this is good when you need to debug and figure out, okay, for this individual patient, what were the key contributing features that drove a model's prediction? So you can see the prediction, the actual outcome versus a model's outcome. So with that, I'm going to leave it as at that. Let's get back. If we can switch back to the slide, Askia, real quick. So this is the demo that we covered today. If you want to look at the open source toolkit, this is where to find out where the toolkit is, and it has very good examples. If you want to learn about both the open source and the Azure Machine Learning Responsible AI dashboard, you can go to the main marketing page. If you want hands-on demo to go through all of these sections and all the different features that we did not cover, you can go to this blog and it's a 8-part series, and you'll be able to go through each component and learn how to debug and interpret your model. Thanks so much.
All right. Well, thank you, Ruth. I appreciate that. Thank you all for joining the session today. And we'd just like to extend, if you have any feedback, we would love to hear it. So let me just get you on. Oops. We've got a survey slide here, and my mouse is now having issues. So I apologize. There we go. So there's our survey slide. So if you do have any feedback, we'd love to hear it. Again, thank you for joining. Thank you, Ruth. And you guys have a fantastic day. Thanks so much.
Okay. Thank you. Thanks for having me.